ஓகே கவ்யா, ஸ்டார்ட் பண்ணலாம்.
Okay, ma'am. Hi, I am Kavya. I am an aspiring DevOps engineer and I have strong interest in cloud computing and DevOps concepts. Today, I am going to explain my first project, which is a Terraform project. In this project, I have deployed a PHP web application. In my case, I have deployed a to-do application, which is a simple to-do application on my EC2 server with RDS. I have used RDS as my backend in this case in a custom VPC.
ஓகே.
So it is my architecture diagram. First of all, I will explain my concept. In my project, first I have created one VPC. And inside this VPC, first of all, VPC is like our own private network inside AWS. Inside this private network, I have created two subnets, which is private subnet and public subnet, public and private subnet. In this public subnet, I have created EC2 server, which is a virtual machine. Inside this virtual machine, I have deployed my PHP application. And in my private subnet, I have created a database called MySQL. In this case, I have used MySQL. So in my to application, whatever the things I am giving, it will store in this database and it will display here. I will show my output in the end of the presentation. So for this EC2 instance, I have also created Internet Gateway. Internet Gateway is like a door to the internet. So we are using this Internet Gateway, we can able to access this application inside the EC2 instance. So I will elaborate this process in my code, in my scripts. So I have created two folders. First one is root files. In this root files, I have uh, five files, which is main.tf, provider.tf. Inside these files, I have declared a variables under the path for that process. So in this modules folder, each operation have its scripts. For VPC, it have that script, and for EC2, it have that own specific scripts. So what is the purpose of modules? Means we can reuse it, the scripts for various projects, so we can slightly make changes as per our requirements. So next one is my root module. In this root module, the first file is provider.tf. This provider.tf, what it says means it will tell which provider we are going to use. So in this case, I have used AWS. So it is telling the provider is AWS. And in this line, which region we are going to deploy our, or we are creating the EC2 instance and we are going to deploy our EC2 instances given here. In this case, I have declared the region in the variable.tf file. So it's mentioned here as AWS region. In variable.tf, I have given the region name. So So my second file is variables.tf. In this variables.tf, what are the variables I have for to create my VPC? So VPC and all. And the first variable I have declared here is AWS region. For this, I have given a description like AWS region to deploy resources. And then this is VPC CADR block. CADR is classless interdomain routing. It is in my case, I have given 10.0.0.0/16. So the VPC can access the IP ranges up to /16. That is approximately 65,000 something that IPs. So the in my VPC can able to access up to that range of IP addresses. And then I have created public subnet. In this case, I have given the CIDR for that public subnet. So we have I will tell that values in the terraform.tfrs file. So in this file, I just created the variable names. variable names only, uh, and private subnet and EC2 AMI. AMI is Amazon Missing Image ID. That is, it will tells about the OS configurations and instance type. It mentions that t2.micro, that one, and then DB username. We have used MySQL here. So for the database access, we have given username, passwords, and then DBS instance class, like DBS, instance type for EC2, it is one thing for RDS database, and then RDS endpoint, it is like a network address that our application uses to connect to RDS, and then it is key name. Key name is like we will generate it for EC2 instance, like a private key, and then text file is terraform.tf vars. Whatever the variables I have declared in the variables.tf file, I have given that values for that variable here. The first one is region, which region I'm going to use, and then VPC CIDR block. It is I have I have mentioned in the previous slide. For my VPC, I am using this uh, range of IP addresses. My VPC have this access, and then inside this, I'm going to implement or create two subnets, that is private and public. For public subnet, I have divided this IP range into /24, so that is 256 IPs can be able to use inside that public subnet can accessible. And then we have created two private subnet. These are for RDS. Public subnet is for my EC2 server, and then private subnet is for my RDS. So then um, for RDS creation, we need to create two private subnets, because we have to store our backups, because one subnet may get fault, means we will use another subnet. So for this case, we have created two private subnets. So why EC2 is created in public subnet means it can able to access in our browser, but we can give our inbound and outbound security groups. But for RDS, we can't able to. Yeah, we can able to give internet services, but only via NAT gateway. We didn't implement NAT gateway in my project. So if we need any internet access for private subnet, we can use NAT gateway. So then next variable is EC2 AMI. Then it is AMI ID for my EC2 instance for this region. So the AMI ID will differ based on the region. Then instance type I have given t2.micro, and my username password I have given here, and then instance class. Then this is RDS endpoint, and then it is key name I have created, and then I have mentioned here. Next file is main.tf. That is root main.tf. It is a Terraform entry point. It will connect all modules. So my first module is I have mentioned here is VPC. Here I am giving that location of that VPC. So for that VPC, what are the variables is needed? I am declared here, and then same as I have given for RDS and EC2. It is my root main.tf. Then it is my root output.tf. Here my output will shows EC2's public IP, and then RDS endpoint, that host name. Then this is my PPC folder inside the modules folder. In this, I have it is same as like that. I have told in that main.tf. It is for CIDR block I have mentioned here, and then I define that as string, and then public subnet CIDR, private subnet CIDR for RDS, and then it is main.tf for VPC. Here I am mentioning my VPC name as proj VPC, and then it is my public subnet. So in this case, I am deploying in USC's 2A availability zone, which it shows as public subnet as a name. So it is
So for what reason you have choosing more than one availability zone?
for backup process, because in if one availability zone may get slowed down, or if it may failed, means we can access through another availability zone.
Okay, so what is the exact DevOps terminology for that word? So you told, right, you have one availability zone, more than one availability zone is for like your backup and for things like. So what is the
So
exact DevOps terminology for that case?
uh, downtime.
It's for your high availability. Okay, so for giving your application to the high availability for users, so that you're choosing more than one availability zones. Okay,
Okay, okay,
okay, you continue.
okay. And then it is a public subnet, and I have declared availability zone, and this map public IP on launch equal to true. This line indicates that we can access this subnet via browser, so it allows for it. And then private subnet for RDS, and I have deployed these two in different availability zones. So then internet gateway. Internet gateway is like a door to the internet. So we have VPC and internet gateway and public subnet, private subnet. But how the public subnet will access the internet means it can access through this internet gateway. For this internet gateway, the route table will tell that EC2 instance how you have to connect to the internet gateway so that you can able to access the internet. That's why we have creating a route table for the public subnet. Then here I have mentioned the CID or block is equal to 0.0/0. So it means any traffic can approach this EC2 instances from any IP. I can access this EC2 instances. In my case, I'm given like this. And then it is route table association. In this process, it will combine that subnet and route table. So this process is like it will associate the route table with our public subnet. And then output.tf, it is a VPC's output.tf. So I have given that both IDs of public and private subnet. So like this, I have created for RDS and EC2. This section is for RDS variable.tf. I have mentioned VPC ID because inside which VPC we are creating this RDS. So I have mentioned here, and then private subnet list of string, because we are getting two private subnets because we have deployed our database into availability zones. So it is getting that IDs from this line, and then I have mentioned the username, password, and then instance class. And then main.tf, here I have given that RDS name as RDS subnet group. Then it is a RDS security group, because for example, if we are creating EC2, we will create a security group for that, like which from which port we can able to allow the inbound and outbound traffic. That we have to give a RDS security group, because using this EC2 only we can able to access this RDS. For this we will giving the security group. And then I have give the inbound rule, like in from this port only I can able to access, like this port indicates my SQL, that is a RDS. And then it is an outbound rule. So then it is a DB instance. So here I have mentioned how much storage it will take, and then my engine is my SQL, and the version, username, password, and then whatever DB subnet group name, two private subnets. So and then VPC security group IDs, and finally I give the name for this. Then output.tf. So it will give the output as a RDS endpoint, that is a host name. Then I have created that similar to EC2 variables.df. Inside this variables.df, I have declared the AMI instance type, public subnet ID. These are all like same as like the previously done process. Then main.df, it is for EC2 instance creation. It is a security group I have created for EC2 instance. It allows SSH as inbound and allows these also inbound traffic. I have followed the HTTP and SSH only, and then it is outbound traffic. I have given all traffic as my outbound traffic, and it is my instance creation. Here I have mentioned the var dot like same as the process AMI instance type subnet ID. Here I have given the public subnet because we have to deploy this in EC2 instance, and then key name same as like that. And inside this user data, I have done small thing like I have in this user data. First of all, I will give the commands, sorry, scripts for installing the Apache web app, web server. And then in this configuration.php, I have implemented a database. For example, what are the input I have given in my to do application? It need to store in our database, and I will show it this in my output section. And then I have created a small HTML and CSS process for my web app. So it is like uh, then I have given how to retrieve that data from that app. So I am giving this line of scripts for that. And finally, my output is public IP. I will get my EC2's public IP as my output.ef. And then final results is I will demonstrate that I will run this app. For example, before that I will say what results I will get. If I run my application, I will get my uh, to do app, and I will show this. Oh, sorry, I am already in this folder. Inside this folder, I have given two bash scripts. Inside this deploy.sh, I have given the Terraform init, plan, and apply commands. So we simply run this command, and we will get our output.
Uh, Kavya, can you just do LS and just list what are the things you're having or what are the files that you have inside this folder? Okay. So once you just
Okay,
created the resources, you just do LS and just show that what are the list of files that you had in that particular folder. Okay.
okay, okay, ma'am.
Okay.
Ma'am, can I cancel this, or I will show this after
No
this
need.
process?
You can just go ahead. Okay. You are creating, right? Don't want to
Okay,
destroy this. You can just show that later.
okay, okay.
Sure. So if you run your EC2 instance, so inside that you have your Apache server and then your application, right?
Yes, ma'am.
Okay.
It takes some time to create.
Okay, okay, no issues.
So parallelly, I will show my files in inside my project folder in another Git bash.
Okay, okay. Yeah, okay.
Okay. Project one is my folder's name, and inside this folder, I have yeah. Inside this, I have two folders. Sorry, one folder which is modules, and another and balance of these are my root files. I didn't create any folder. I simply given us these files, and so assume these as my root files. And inside this modules folder, I have my three folders. So that is EC2 and RDS. Inside this, I have separate file like main.tf, output.tf, variable.tf. So it is similar to these two folders also. So let's we check. Yeah, we finally got our output. It is our EC2's public IP and it is RDS endpoint, that is host name. So we can we cross check it on in our AWS console. So yeah, the instance is created and it is running. So let's we check by taking this public IP. Just setting. Yeah, I get my screen like my page. So I simply created it by PHP and HTML CSS. So if I add any task, I can add and then I can view and also I can delete it. So this is my whole entire project. That's it, ma'am. Thank you.
Yeah, super. Actually, it's really a good concept, Kavya.
Thank you, ma'am.